All right, everyone. We are ready to start our next talk. Our next speaker will be Brad Richardson and Madhav Bhatt. Brad is here to talk about the red team engagement in GCP. So take it away.
Thank you. All right. Good afternoon, B-Sides. Thanks for joining me. This will be red team engagements in GCP. And we'll be talking about what it's like to do a red team engagement in GCP. A lot of it will come from taking our typical attacker objectives, the tactics that any red team finds itself walking through, and we'll be applying it to resources that are unique to GCP. A lot of what you'll see is kind of what I call living off the cloud. So you've heard of living off the land. This is more living off the cloud. So we'll be taking normal functionality and we'll be using it red team style. And I just want to point out that Madhav Bhatt would have been here. He had a personal conflict. We would have co-presented this together. I know he was super bummed that he couldn't be here with us today. A lot of what you're going to see, he has directly contributed to it. A lot of this material comes from him. I'll also be talking about a tool that we co-wrote together, but even a lot of that is his evil genius. I want to make sure that he gets proper credit. So just jumping in, quick disclaimer. A lot of what we do, even though we're professional red teamers, is done on our spare time. It's our own views that we've developed over several years, doing red team engagements, both for with the government, also just typical corporate. But what you see not necessarily reflects anything from our employer. But really just what comes out of a lot of our own personal research, personal tool development, that kind of thing. So with that out of the way, who am I? Of course, I'm Brad Richardson. I tweet at RichardJB, OffSec engineer, currently at Credit Karma. I like to blog things I think are practical, useful to the security community at Medium. And probably my most recent tool, at least the one that I'm kind of proud of, is called SlackHound. It's a reconnaissance tool for red teams for Slack workspaces. So check that out. And I'll introduce Madhav. He tweets at Desi Jarvis. Also, we work together. He's an OffSec engineer at Credit Karma as well. Blogs at Medium, writes tools himself, and he's a contributor to a Atomic Red Team. So I said that we would be walking through typical tactics, phases that any red team would go through, in this case unique to GCP. That's exactly what we'll do. So we'll orient ourselves a little bit to GCP. We'll walk through a little bit of an initial foothold. We'll go through persistence, privilege escalation, command and control, lateral movement, and we'll finish off because normally, we need to do all of these things to accomplish our objectives, but often, more times than not, our objective is about data. And we'll talk about data and decryption, exfiltration. So just a little bit of GCP 101. So if you're into pictures, GCP kind of looks like this from an attack perspective especially. So at the top level you have your organizational node. That might be your domain, redteam.com. Below that you may have suborgs, and below that projects. And really projects is where your resources are going to be under, where the magic's going to happen. When I say resources, you think of your compute, your storage, secret management, network, those types of things. And if pictures aren't your thing and lists are more your style, This is the same thing in list. So you have your organization at the top. Your projects will fall under that. In larger enterprises, you may encounter folders. Folders are, I think of those as ways of just organizing like your IAM permissions. Maybe you think of like having departments. Those fit neatly up under folders, but you don't have to have folders for GCP, but you definitely have to have projects, and under the projects, like say, will be your resources. So we'll jump into a little bit of initial foothold. I won't spend too much time on this. Hopefully, if you are doing red team engagements, you're at a maturity level where you're spending the majority of your engagement in other attack phases, so that you get the most information kind of across the board. If you're spending a lot of time in initial access, you're trying to do phishing, you're trying to, at that point, prove maybe that more of an attacker or advanced attacker can get into the environment, then you may be losing time is money, and data from how your defenders respond in those other parts of the kill chain. But with that said, there's nothing wrong with working in initial, getting an initial foothold. A lot of good data does come out of that. So I wouldn't want to leave you without some information in this attack phase. One thing, I mentioned phishing. If you are using this attack vector, definitely check out a write-up by Cedric Owens. He talks about how to get a tool called Evil Jinx up and running. Evil Jinx really makes phishing a lot easier, especially if your organization is using identity portals like Office 365 or Okta. Could be any of those SaaS-based identity portals. Evil Jinx makes this easy. You would still do your typical phishing, but the man-in-the-middle attack takes a lot of the pain out of phishing, where you're trying to set up a site, scrape a lot of CSS, make it look legitimate. Well, the man-in-the-middle attack will do what you want, which is capture those username, password, credentials, potentially bypass 2FA, and get you a valid session into that portal. One thing to be on the lookout, because it's GCP, you're probably familiar, red teams are always looking for credentials, maybe in, if you're doing AWS, maybe in S3 buckets. If you've compromised endpoints during your red team operation, you're looking at traditional things, keys and different types of secrets, and you're looking for specific file extensions that'll maybe lead to something that'll help you laterally move from your initial foothold. Well, for GCP, look for JSON file extensions, P12 files as well. The difference being here, as I like to think of them, as one is more Google managed keys, and the other one more customer managed and uploaded. And don't want to discount traditional methods of getting initial foothold. So things like SSRF vulnerabilities still come into play. It doesn't matter this GCP. So one other thing I'll point out on this slide is maybe you're aware, maybe you're not. It's been reported to Google. If you're using programmatic access like gcloud, gsutil to do a lot of automation for GCP, the credentials are stored in clear text. That's what you'll find under a compromised endpoint, or it could be even yours, your home directory, .config/gcloud. If you find credentials in there and there's an active session, all you need to do as the red teamer, download those files, and you can take over that session, assuming, again, it's a valid session. Those do time out, but if it hasn't, you can assume that session. This is not unique to GCP. Certainly none of what I'm saying I ever intend to pick on GCP. AWS and Azure, it's a little bit different, still suffer the same kind of issues. And so if you haven't heard of this particular technique, there's a write-up that Madhav did about how to go about doing this, exfilling those databases. Of course, if you're getting a foothold on an endpoint, you at least have the privileges of that user that clicked on that phishing email or whatever it is. It's not going to require root or administrator privileges. And so you'll be able to read those database credentials and download that. Should be able to. And I know I have links here. I think that they're going to make these slides available. I've also linked to it so that you can download in PDF, and all the links are available. You can go out in your own spare time and read these write-ups. But continuing on, we won't spend too much time here, but just if you're not familiar with what like service account keys look like and credentials in GCP look, how they appear, and you find yourself in an engagement in this cloud environment, you see this is an example here. The things that help orient you, we're using gcloud, and we see that we have the project that we're in. So if you think about getting a foothold on an endpoint, you want to get situational awareness just like you would in an on-prem traditional network. So you see just a few commands, or looking at that service account key, you see your project, and pretty much everything in GCP kind of looks like an email address for service account. So you see that at Red Team Project 1 and gserviceaccount.com. Just be aware of that. So we'll jump into persistence. Two main takeaways here. What you see on the left side, if you're gaining initial access via a user account or access token, and you're working as a red team, these are short-lived account access. So red team needs to move fast if you find one of these and it's an active session. Whereas if your initial access comes from a service account, you are good. These are very long-lived sessions, and I'll show you a little later just how long by default. But if you come across a service account, and that's why I point out the extensions, why they're important to keep an eye out when you're doing reconnaissance, where you land on an endpoint, you may have just killed two birds with one stone with the ability to have your persistence and hopefully move laterally. And here's what you see, very tactical examples. So at the top, we're working with SSH keys for persistence. You see the Google Cloud Console, web-based GUI, and in here you have the SSH public key for the test account, and below you see what it looks like from the CLI. So I've catted just a fake public key. You see the key there, and what you see in the red box is successfully adding using Google's own built-in SDK. So in this case, we're using gcloud compute instances, add it to the instance that we want. We can give it a local file, in this case, the public SSH key portion, and it works. And tying back into the top here, the key is added. One thing that I want to point out is very important. If you think about the format of the public key in your traditional Linux host, it's a little bit different than what Google expects. So if you're using this method, you want to take note. We have the account, the colon, SSH RSA, a space, the key material. If it's not in this format, Google may or may not throw an error, but you'll go to log in or SSH in, and it won't work. And you may not know why. So I want to point that out in case you're using this method. And so kind of going back to service accounts, here you see the Google Cloud Console. One thing to note is in GCP, a service account can have multiple keys. If you come across a service account and you see a key, you obviously don't have the key, but it doesn't mean that with the right permissions that you can't add additional keys. You can. And also, I said that service account keys are long-lived. In this case, by default, they're good till December 31st, 99.99. I call that long-lived. And so, to me, one of the funnest things about red teaming is when I can find normal built-in functionality and kind of turn it towards the advantage of the red team. So in GCP, you have startup scripts that you can attach to compute instances. It will execute those. They can be very complicated. You can also find keys and tokens as well in startup scripts, just normal admins working to make things do what they want. But we can use this functionality as well. So what you're seeing again is a very simple example, but it doesn't really matter. It will work. So I create my example shell script here. I chmod it to be executable. I use again the Google provided SDK gcloud command. I give it the instance that I want, and in this case I can run it. I have that script locally, and it will attach that startup script, and when this host, whenever it reboots, it will execute my code. In this case, what it's doing, you see it there in the Cloud Console where it's been added, and below you see rooted instance 3. I grab the host name, and then I check to see that that file was successfully created, cat it, so it's in etc. You see beacon.sh, and I just echoed the command for the example, and you see the text there. My beacon runs on bacon, and so our startup script worked. Of course, in a real red team engagement, you're going to put something besides that. Sometimes, depending on how the enterprise has architected these things, maybe you don't have CLI access, or maybe you're just more comfortable working in more of a GUI-based interface. No problem. If you need, once you have this persistence, you're able to log in through whatever method. Thankfully, GCP supports SSH login through the browser as well. And establishing persistence on project. What you see here is you can add even Gmail accounts to the project. So once you have enough IAM permission and you want to add an account, that doesn't necessarily have to be an email address in your organization. When I've tried this, it will complain if it is outside of the organization's domain or Gmail, but Gmail works. Even though you think redteam.com, it would need to be a redteam.com address. I assume that there's functionality to disable this, but by default, works just fine. And Google will send, or GCP will send the email to the email address that you specify, and that's what you see on the right side. So I invite you to join the Google Developer Console. The project's redacted there, but once you accept the invite, whatever role you were granted, you're good to go. So persistence on project, again, just continuing. I mentioned earlier, be on the lookout for JSON keys. Once you have the right permissions, you go to create a service account. It's going to give you the ability, it's going to ask you to download and save that JSON file that is the service account key. Whenever I see in any application it warning me something to the effect the service account keys could pose a security risk if compromised, that's very interesting to me as a red teamer. And so here, again, we're just downloading the key, and now we have that persistent access. And again, you see we're doing persistence, and we can add even a Gmail address, in this case, for the organization. So even escalating our privileges a bit, and the role we're setting is owner in this case. However, a bit of this sounds kind of simple, right? We've all seen where you're working in test labs. Test labs are very small. Everything is very default. You know, a large company may have thousands of projects, may have you know, things broken out into folders, using, you know, lots of different resources. And so, of course, you need the appropriate permissions. That doesn't change in the cloud from how it is on-prem. You still need that, you know, that level of access to do these things. And so finding the right accounts, finding the right compute instances, just as much challenge as it is in on-prem networks. So what do we do about that? Well, we'll talk about privilege escalation, but I want to also bring up a tool that me and Madhav have written together. It automates a lot of what you have seen in this presentation and a lot of things that will come. If you are in an environment where you're talking about, you know, hundreds, thousands, tens of thousands of projects, lots of accounts and different roles, be too overwhelming for, you know, maybe your red team's 5 people, 10 people, or smaller. You would burn all your time potentially trying to figure out who has the power in the kingdom. gepHound really helps with this. So I have a link there. This will take you out to the Medium article Madhav wrote. It will tell you how to download gepHound, get it up and running. It runs in a Docker container, very lightweight. Currently, it helps abuse IAM, compute, project, GCS, KMS, a lot of the things I'm talking about, and I'll show you examples of it as well. So, it queries IAM in this case. It also has a GUI for the IAM portion. I think we will add all of the modules and all the functionality to eventually be under GUI. But we started with IAM because of just how do you decouple when you're talking about so much data. And so that's what you see here. Hopefully you can see it. Might be a little blurry on the screen, but it just makes it more clear when you're trying to find out who has, you know, the roles that you're going after. It is fast and stealthy. It is multi-threaded. It does random sleep time to potentially throw off, you know, rate limiting or the blue team. And so it is also customizable. By default, it will populate this file. These are typical juicy accounts that you'll probably be going after, but you can change that. If you find in your organization there's a particular role, you know, maybe it's custom, it's unique, and you want to add it in here, this text file, no problem. And it will pull all that data in and show it in a nice GUI for you to help you out. So escalation and persistence. Remember we talked about service account persistence. You know, you can run the gcloud commands, certainly. Some of those get pretty lengthy, quite a bit to type at times. gepHound helps shorten that. It also helps automate, you know, what we're really trying to do, save us time. So what you see here, gepHound create service account key. You give it the project, give it the service account that you want created, and there's a couple other things that, you know, Google GCP expects. But what it is doing here is it will check to see that your session is still valid, that you're still logged in, and it's going to create some local directories for you, and it will attempt to create that service account. If that service account already exists, you might recall we can have multiple service account keys. It'll go ahead and download that key, store it for you so that you have it to use, and a little bit of automation. So, of course, if we can become owner, let's become owner. And gepHound, as it does the first part of that, it'll also go ahead, assuming it has the right permissions, it will attempt to put you in the owner role as well for that service account. And what you see here, it's a bit redacted, but you see the green box, it was successful up here, and you see kind of validating it in the Cloud Console, our service account that we created is owner. And you see we got a nice 5578 out of 5578 excess permissions. So we'll jump into a little bit of command and control. Not every engagement requires that you establish C2, but it's always nice to have. So if you're doing red team engagement in GCP, and let's say you're working in a really restrictive environment, well, I'll leave you here with two potential options. The first one is to use Google Sheets. So I wrote a Medium post, and I also put it out in my personal GitHub, some Python code that helps you establish C2 using a Google Sheet. What I like about this is that it's a little harder for Google to block Google, so GCP back to a Google Doc. By default, of course, it runs over HTTPS, so our channel is encrypted. We didn't have to do anything special for that. If you go this route, it really only requires a couple things to get up and running. The nice thing about SAS is it helps us out here. So you need Python, you need a GCP service account. That GCP service account doesn't need to be privileged. I don't think that it even needs to be in the project that you're targeting. You just need a GCP service account. And of course you need a Google Sheet. And you will need to enable the Google Sheet API to get this working. But other than that, you don't really need anything else. And if you check out the Python code that I put out in GitHub, it's not going to be as full-featured as something like Mythic or Cobalt Strike, but it doesn't mean that you can't do your initial reconnaissance, establish situational awareness, and then I built in a command so that it will download whatever you point it to. It's not going to use curl. It's more Python, sysinternal. So it's a little bit stealthier than running, running something on the command line to download potentially, a payload that you want to use to upgrade your C2 from this to something more full-featured. But there's also DNSCat2. I didn't write that. I did put the author up there. This works really well if you find yourself in a super restricted environment. ACL is really locked down. You can't, make it out to the internet on any. It doesn't seem like you can make it out to any TCP or UDP port from a project because it's that restricted. Well, normally, typical DNS functionality, Google will help you out by forwarding, the client queries outbound to the internet, and so that may be an option for you. So I did say that you need to enable Google Sheets API and create a service account. These are really simple to do in GCP. And an example of what it looks like with my Python-based C2 over Google Sheets. So what you see up here in the top portion is just running the Python client. It is calling out to that Google Sheet. If you're familiar with Google Sheets, the same way that you share a sheet with a person normally looks like an email address, right? So remember we talked about how the service accounts look like an email address. We just take our service account ID and share it with that. And then our sheets here, I've added a couple columns to make it just more manageable. You see C2 command output, timestamp. So the client reads from that cell, very simply, grabs the who am I, executes it up here. We see that it's root. It'll automatically go to the next row. So it cats SEO release. We get our situational awareness. We see kind of the operating system where we're working from. And we can do curl -version. And we see that there. And it timestamps each of it. Each command that it runs, which is always helpful to the red team because we're trying to manage the red team log and be able to go back later and say what was the host and when did we execute it. So this helps with that too. So we'll dive into lateral movement. So by default, every compute instance in GCP has a compute default service account attached to it. Now this can be customized, this can be changed, but just talking defaults, in large environments, especially you might find variations of this. By default, that account has the editor role. However, this does not mean that you can use all of those permissions. So if the account has an active token, a session that you're trying to abuse, what you see here is we can run a few simple gcloud commands and sort of orient us to the host that we're on. So gcloud auth list, projects get an IAM policy, and what you see in the screenshots is that being ran. So you see in the red box at the top, that tells us that the host that we've landed on is using that compute default service account. And then you can curl the metadata server from the compute instance, just like you see here, and that will come back with your access scopes. So kind of two things determine what you can, what APIs you can query in GCP from, say, a compute instance. And so IAM permissions are only half the battle. What you see here is actually pretty restricted. The access scopes determine what we can do with those other cloud resource APIs. By default, it is pretty restricted. So you see, you have some read-only permissions for storage and monitoring, trace append. But if you land on a compute instance and you have that editor role and you query and find that you have access scopes, like, for example, if you see cloud-platform or a whole lot of additional permissions, life just got a lot better. That means you have a lot more access. So I wouldn't want to leave Windows out. GCP obviously supports Windows. Not everyone is in a Linux environment. Here, we are targeting a Windows host. Let's say in our red team engagement, all of the data that we're after, or whatever the objective is on a Windows host. Using the gcloud command, we can use gcloud compute reset Windows password, give it the instance name, the zone, and the user account. Now, if that service account does not exist, and we have the right IAM permissions, this is all we need to create that service account. GCP will do this very easily for us, and it'll also drop it into the local Windows administrator group. It returns us the password that you see in here, and we're good to go. If we're targeting an account that does exist, we know it exists from reconnaissance or some other means, we do the same thing. It'll change the password. It'll give us a password, and we're good to go. So again, I love it when we can take normal GCP functionality and use it for red team purposes. What you see here, GCP includes the ability to patch our GCP instances at scale. You can set up patch jobs so that, if you want to target one, say Linux compute instance, you can. If you want to target all Linux compute instances, you can. Whatever subset. If you're really gutsy, not worried about triggering alarms, you can tell it everything in the project. But in this case, what you see is we're using gepHound to make it a little bit easier. We give it an instance. Just like with normal GCP functionality, we can specify a local file. We can specify a file that's in a Google Cloud storage bucket. And what we can do is we'll run our patch job. We'll patch the compute instance just like an admin would, except we'll also run our code. We can use a script, apply it to the compute instance. The only thing about it is like with normal patching, it probably will reboot the compute instance. But it's fairly stealthy, and so sometimes your admins will be like, "Why did the host reboot?" Oh, well, looks like it. There was a cron job or something happened. We see that what it did was just patching, so that's why it rebooted. We'll make a note of it. So you might get through even though it rebooted as a red team. And what you see down here in the Cloud Console is you see the patch job was successful. So it patched the host. When my patch job patch it real good, and it would have executed our code as well. Pretty stealthy method. One thing I'll point out here is if you use this method and you supply a GCS location, so you have your script that you want to run on the host, you need to turn on versioning. This was not very clear to me at first, and I kept wondering why the past job was failing. If you call a script in GCS, versioning needs to be turned on, or it won't work. So back to lateral movement and using SSH keys. What you see here is we're using gcloud again. We can modify the metadata for the project. Of course, we can do that with the compute instance as well, and we saw that. If you're using gcloud or gepHound to add an SSH, your SSH public key to compute instance, you see that in the metadata for the compute instance in the cloud console. In this case, we're looking at the project. What I point out here is what makes this particularly cool is if we add it to compute instance, well, we can SSH into that compute instance. But if we add it to the project, then we can SSH into every compute instance in that project. Now, I'll point out that there's a way kind of to defend against this. You can set in the compute instance to ignore keys, but generally, you're probably not going to find that to be the case. And one other thing is if you add your SSH key to the project metadata, then not only do you have SSH access into your running instances already, but an admin goes in tomorrow, the next day, builds more compute instances, you'll have access to those as well. And I said earlier that when doing C2, firewall rules may be restrictive, may find yourself in a particularly restricted environment. But this is kind of what it looks like by default. So you may not. And so you see, if you just go build a standard project, this is what your firewall rules will look like. So you see ingress rules here, ICMP, all TCP ports, all UDP ports, and default rules for 33, 89, and 22 for SSH. Doesn't mean that admins can't restrict this, tighten these rules up, use least privilege. Of course they can, of course they should. We're there to help the defenders defend better, but just to show you what it would look like by default. And gcloud compute SSH. This is a particularly nice feature in GCP. So you think about normally SSHing into typical Linux box. Well, you can use gcloud compute SSH, and you see up there in the red box, we give it the instance name, we give it the zone. Assuming we have the right IAM permissions, it'll ask us for the passphrase of our key, assuming we've set a passphrase for our key, and we're in. We don't have to have an external IP address. This is a difference between your traditional on-prem networks versus the cloud. In this case, on-prem network, we might need to set up some natting rule, firewall rule to route from external to internal. Google GCP takes care of this for us. Assuming we have the right permissions. The instance I used in this example did not have an external IP address or ephemeral IP address, only an internal, but I had the right IAM permissions to execute this gcloud command, and I'm able to SSH in. One other thing that I'll point out here is you see the red box around the 35.235.240 IP address? Well, that's not my home IP address or external IP. That's Google's IP address. So I get a little extra stealth out of this. I didn't have to do anything for it. If someone's looking at who logged in and from where, well, it looks like I logged in from Google. And last section, we'll talk about data exfiltration and decryption. The other sections, those are things that red teams have to do. Those are the tactics that we typically walk through to eventually be able to action on objectives. More times than not, the real objective, has something to do with data, right? So we're trying to test the assumption that a determined attacker could get to wherever the data is kept. Could they read the data? Could they modify the data? Could they exfil the data? So a lot of times it's all about the data. So here you see we're using gepHound. A couple of different functions that me and Madhav have added to make this more simple, less to type. So gepHound bucket list and exfil bucket. So again, you're working in a big environment, could be hundreds, thousands of buckets, could be lots of objects in those buckets. A lot of times red teams are drinking from a fire hose. There's so much to go through. Red teams, aren't exactly like a nation state where you think about red team airplane hangar. Usually red teams in corporate environments are pretty small, and it's tough, right? So gepHound helps through that data a lot more quickly. So you see we think we've come across a project. That project looks interesting. We can use bucket list. gepHound will check that our session is still valid, make sure we're still logged in, and it will pull a list and it will start querying everything in GCS for that project. And what you see here is in my test environment that I've created, it is pulling all of the available buckets and downloading them to my local machine. And so there's your listing and there's your exfilling, all made simple. Of course, the data may be encrypted. We need to decrypt it, otherwise it's useless. In Google, you have KMS. That typically helps you encrypt the data. gCloud, of course, has commands to both encrypt and decrypt the data, to store your keys, create your key rings. But what you see up here, although a lot of it is redacted, of course we can do traditional things like we cat the data and we see we would see that the data is encrypted. We can type out these very long GCP gCloud commands, and they work, of course. And once we find the right key from the right key ring, we can decrypt the data. But again, if you're in a very large environment, it would take a lot of time. gepHound root decrypt, we just need to give it the project ID, give it the keyring region, and the file that we want. So it doesn't matter how big the environment is. It, again, checks to see that the session is valid and that we're logged in. It will go out, and based on those few parameters we had to specify, we gave it the key ring, and you see with the green box around it, it's trying the keys from that key ring, and it will try every key until it finds the right key for the data you want decrypted. Once it does, you see decryption successful, and it stores the output there locally for us. And of course, I put just a B in that file, but basically showing that the file was successfully decrypted. And so just kind of closing remarks. We went through things that I think are practical things that red teams can do to live off the cloud, take the resources that are there, and use them from a red team's perspective. We talked a lot, around compute, a little bit around like KMS and encryption, GCS. But there's a lot more, right, that we didn't cover. This is just a subset. GCP is really powerful, a lot of resources and functions. You think about cloud functions, secret management, firewall policies, we really just scratched the surface. But hopefully those examples were very practical and down to earth. And if you're starting a red team engagement in GCP, maybe you haven't done one before, or maybe you have and you just wanted to see, what's an approach that, another red teamer might take. Hopefully that's been helpful. And kind of just thinking about the cloud security, and I talked about gCloud Compute SSH, how you didn't have to have an external IP address, but you would still, in some cases, it would create an IAP tunnel for you, allow you to SSH in. We have to kind of think about the security issues we had in on-prem traditional networks and how they might be the same in the cloud, or they might be a little bit different. Our job as a red team is to validate assumptions, Don't just assume that the security controls that we're helping to build, helping to mature, work. Of course, not picking on security vendors, but they always work according to the security vendors. But we have to test those. We can't take it for granted because we want to make those security controls stronger, and validation is part of that. So be careful. Cloud infrastructure may not be any more secure than the on-prem version that you had before. The cloud provider may or they may not provide the basic security controls. You know, IP whitelisting, very basic, been around a long time. Don't assume that, you know, that it's just taken care of for you, or that it even, you know, can be done in some cases. And of course, you know, it's 2022, a lot of these things seem like stuff that, you know, we as a security industry should have fixed a long time ago, but not necessarily. So you assume that any car you buy in 2022 comes with airbags. We can't assume just because it's 2022 and we're in the cloud that things are just naturally by default more secure. You heard me talk about a lot of configurations in the way that it's set up when it's default and how it can be abused. Well, just don't take anything for granted. And with that, I appreciate everyone coming out and listening to the talk, allowing me to share some information. Hopefully you found it helpful. Big thanks to BSidesSF for allowing me to share as well. And if we have any time left, happy to take questions, or if you'd like to chat afterwards, happy to do that as well. Yeah.
I saw one of the persistence factors was creating a new service account.
Mm-hmm.
Are there any artifacts, like email artifacts, that happen when those service accounts are created, perhaps to the user that you're creating service accounts for and things like that?
Yeah. So the question is when you're using or creating service accounts, potentially for persistence, are there any artifacts left around? Such as like an email, you saw in one of the screenshots where you get the email, in one case, to accept, you know, that invite. From what I've seen, it's actually an option. So you can tell it not to, if you're trying to be particularly stealthy and not generate that email, or you can generate the email. Is it an artifact in that case? I would say it is, especially in the case where, let's say that you've compromised an employee account and you have access to their email and you generate that artifact. Now, an attacker could set up a rule so that that email goes into trash very quickly, but that's still an artifact, right?
Absolutely.
And you could potentially alert on that.
Cool, thank you.
Yep.
Thanks so much. I have a question about the OS patching management. I'm not that familiar with that feature, so I'm just wondering, is there possible for the admin to configure to check integrity or authenticity of that patch to avoid the attack that you just explained?
So the question is could an admin potentially check the integrity of the patch? So I believe that is the case. However, it becomes, in my mind, detection versus prevention. So when we create a script that we're going to attach to the compute instance and run after the patch job completes, as far as I know, you would not be able to, by default, functionality that's built in, be able to detect or be able to check the integrity of the script that you're running without kind of creating something custom, as far as I know. In the example that you saw, I did not tamper with any of the actual RPMs in the patch job that were pulled down. I just created my own pre and post patch script to run. So as an attacker, probably what I would do is then go and see if I could remove that patch job. Of course, as red teamers, I don't really like to remove the artifacts. I want to leave it there for the blue team to potentially investigate, hopefully find. But the best I can answer your question, I don't think it would be an integrity issue. unless you built something. Could be wrong, but that's what I think.
How about the authenticity? Like, is that possible to configure? So, for example, you need some signature in the patch, and check the signature to make sure that it's from a legit origin.
So if you're wanting to check the integrity of, like, for example, the RPMs that'll be pulled down and installed, yes. You can check the integrity of your RPMs. You can limit just, typical patching. You would want to do that anyway, or I would want to do that so that no RPMs got installed that didn't come from validated, verified RPM repos. Yeah.
Thank you.